Right.
Yeah, my question was just gonna be like, do we have like a set midterm for this class, or is it just more like we just keep doing our assignments and stuff
It's,
as part?
it's not really a midterm exam. It's just exam two. It's just the next in the sequence or whatever.
Okay, so would it just be like on Pearson, or is it like?
Yeah, the same as exam one. Yeah.
Oh, okay. So we just keep working on our Pearson stuff, and then we just take exam two, basically.
Yep.
All right, I see. Thank you.
And that actually leads me into the announcements for today. That was part of what I was going to mention. Where is it? There it is. Okay, let me check this one more time. That looks good. Okay. So yeah. Come on. All right. So let's see. As far as announcements, so welcome, gentlemen. We are at the top of week 7, right? Captain's log. That's what it feels like. But yeah, so as you heard in like the opening questions, that means that we can anticipate exam 2 to become available this Sunday, right? So I think I scheduled it to become available this upcoming Sunday at 11:11 a.m. And it'll be due the following Sunday at 11:59 p.m., right? That's Sunday night going into Monday morning. I want to say that this upcoming Monday and Tuesday is fall break. So I think we have that Monday and Tuesday off. So I need to confirm it. But if that is the fall break, we won't meet. Everything on Pearson is going to stay as is, but we won't be doing this kind of session. Let me see what else. Yeah, so it's not really a midterm, it's just exam 2. And then so when I go to calculate the midterm, my goal is to like not pull the data until after exam 2 is due. I do acknowledge that there are some students that, for whatever reason, still have not purchased a full access to Pearson, and that's actually okay. But if you intend to, it's kind of weird, but like if you intend to finish my class, you do need to purchase the full access to Pearson, because that's how I do my online management or whatever. But as long as you gain access by the end of the semester and get your stuff submitted. If you had the temporary trial, then, it saves your work, right? So once you gain full access, all the work that you did during the temporary trial will still be there. And then, the hard deadline for everything is that Friday, that Friday at the end of the week of finals. So with the midterm grade, it has no bearing on your final grade, right? It's just a snapshot of where you are at this moment in time. So, like if you don't like your midterm grade, then it's just an alert saying, hey, you got to shift gears. You got to do something different, right? To bring that up. If you do like your midterm grade, then you say, okay, that's one checkpoint. Then the next checkpoint is not only getting to where you want to be, but maintaining that status, right? One level is getting where you want to be. The next level is how long can you maintain that, right? So that's in life. It's the same thing. But again, the midterm has no bearing on your final grade. Okay. I can't think of anything else, right? And you guys got it. So if you have questions, feel free to unmute yourself to get my attention and ask your question, or you can type it into the chat. I check the chat periodically, and I do intend to check. I do intend to check Zoom again at about the 15-minute mark for any latecomers. There was something else. It'll come back. I'll bring it up later. I can't think of anything else that's pertinent. Okay. All right, so today we're going to be wrapping up chapter. Come on, there it is. I don't know why I was acting that way. Let's do it like this. View, single page. So we're going to be wrapping up chapter 1 with section 1.6. Now, exam 2 should be focused on like the second half of chapter 1. So 1.4, 1.5, and 1.6. But, math kind of by default is cumulative because, if I'm asking questions from 1.6, but that's based on 1.1, 1.2, and 1.3, right? So even if I ask questions solely from 1.4, 1.5, and 1.6, it's still piggybacking off of the previous stuff. So kind of by default, math is cumulative. Okay. So with section 1.6, we're going to take a look at combining functions. Now, we're not going to have enough time together to get through all of these concepts. So far, we haven't been making it past the third objective in the classroom setting, right? But because of that, that's why I went out of my way to make the pre-recorded lectures. So all the stuff that I want to say for this section is already available on my channel. I think I make the links available in the descriptions of each video, to a link to the full lectures. Okay, so we'll do the best we can together, and kind of go from there. So a few objectives here for section 1.6, combining functions and composite functions. We like to define basic operations on functions. We like to form composite functions, find the domain of a composite function. We like to decompose a function and apply composition to practical problems, okay? So first we have this sum, difference, product, and quotient of functions. And let's do it like this. So let f and g be two functions. The sum, f plus g, the difference, f minus g, the product, f times g, the quotient, f divided by g, are functions whose domains consist of those values of x that are common to the domains of f and g, except for f divided by g, where all x values that make the denominator 0 must be excluded. These functions are defined as follows. So f plus g of x, what this means, this is function notation, right? This means f of x plus g of x, okay? A common error that students do is they treat this like multiplication and they try to distribute this x. That's wrong. That's no good, no bueno, right? This is not multiplication, this is function notation. So this notation means f of x plus g of x. Or in other words, this notation means the function f plus the function g. Okay, it's not multiplication. This means f minus g. This means f times g, and this means f divided by g. And again, we have to throw out any x that makes the denominator 0. Okay. All right. Now this has been kind of not working all day, but we can give it a go. I think we've been using about 3 pages. So yeah, still doing the thing. Yeah, for some reason, when I go to add a page, it crashes. It's been doing that all day. Come on. Let's see. Right. We left off here and we need like 3 pages. 1, 2, 3. Okay, we left off here. And one other thing, I'm gonna go to seamless. Okay. So given that, here, we need to take some notes. So I'm basically just gonna get a copy. Given that f of x is this guy here and g of x is this, we're asked to find each of the following. Okay, so I just wanna get a copy of all of this. So I'm just gonna write it down. So then my f of x is x squared minus 6x plus 8. My g of x is x minus 2, okay? For part A, we're asked to find f minus g of 4. Part B, we're asked to find f divided by g of 3. Part C, we're asked to find f plus g of x, okay? C, D, we're asked to find, oh, and then it's just all the compositions, right? F minus G, A, B, C, D, E, F times G, and F divided by G. Okay. So for part A, let's do like this. So for part A, we're asked to find f minus g of 4. Okay. So again, let's go like this. F minus G of 4. Again, what this means F of 4. So the function F when X is 4, whatever that answer is, minus the function G when X is 4. Okay. So let's go ahead and find F of 4 first. All right. When I think of F, I think of fuchsia. So this is what I think fuchsia looks like. Hot pink. F of 4. So if we're going to evaluate F when X is 4, we're going to replace each X with 4. The first recommendation is replace each X with a blank set of parentheses. So we're going to say X squared minus 6X plus 8. Okay. And then we're going to plug in 4. Again, the blank parentheses, what they do in case we're plugging in a negative, it helps us to keep track of the negatives, so we're less likely to make a mistake. Okay. So then if we evaluate this, that's going to be 16 minus 24 plus 8. I think that result should be 0. Then let's go ahead and find G of 4. Okay. G is X minus 2. So it's going to be X minus 2. And again, X in this case is 4. So that result is 2. Come on. There we go. Okay. So then this ends up being 0 minus 2. And the final result there ends up being negative 2. Okay. Okay. All right, that was part A. So then for part B, F divided by G of 3. Okay, part B, we're asked to do F divided by G of 3. Okay. Again, this means F of 3 divided by G of 3. Okay. So if we go ahead and do F by itself, so then F of 3 is going to be X squared minus 6X plus 8. Again, X is 3 in this part. So that's going to be a 9 minus 18 plus 8 ends up being negative 1. And then we need to go ahead and find G of 3. G is going to be X minus 2. So that's going to be 3 minus 2, which is 1. So then F divided by G of 3, F of 3 was negative 1. Divided by G of 3 is 1. And then the final result ends up being negative 1. So again, if anything isn't clear, just have to get my attention. Okay. And then I think the 4 remaining are compositional functions. So we're just like, for instance, AB, for part C, it should be F plus G of X. Again, this means F of X, F of X plus G of X. All right. Okay. F of X is X squared minus 6X plus 8. Oh, well, we don't have to write it this way because we're not evaluating. Okay. Since we're not evaluating, we can just go ahead and write it in one line. And then we're going to say plus our G of X is going to be what? X minus 2. Now notice we don't have to distribute any negative. We're not multiplying the outside of this function by a negative, so we don't need any parentheses here. So then all we need to do is combined like terms at this point. So let's see, we got an x squared. Negative 6x plus x is going to be a negative 5x. 8 plus negative 2 is 6. Okay. Okay. And then ABCD was f minus g of x. Okay. This means f of x minus g of x. Okay. Now, I want to highlight this negative. All right. Okay, because that should alert you to something, right? Okay, so if we keep going, f of x, we can just bring it down, but this time I'm going to do this. We got our x squared minus 6x plus 8. Then we're going to say minus g of x, which is this x minus 2, right? So notice, I put that red minus in front of the green parentheses because hopefully you should catch it now. And I included parentheses this time because we have to distribute this negative into the function g, right? We didn't have anything to distribute in part C, so that's why I didn't include the parentheses. Okay. So then we'll get x squared minus 6x plus 8. Then we're going to say minus x plus 2. Then if we combine like terms, x squared minus 6x minus x is going to be minus 7x. Minus 7x. 8 plus 2 is 10. Okay. Hopefully this is okay. Hopefully it's okay. Okay. A, B, C, D, E. I think E was multiplication. I think we got enough space. So then part E was f times g of x. Again, this means f of x times g of x. Okay. So then our f of x is x squared minus 6x plus 8. And then we're saying times our g of x minus 2. Okay. So we essentially need to FOIL. Every term in the green needs to be multiplied by each term in the previous. All right, so we're basically foiling. Okay. So if I FOIL or expand it out, x squared times x is x cubed minus 2x squared. The next is going to be negative 6x squared plus 12x. And then last, we're going to have plus 8x, 8 times 2 minus 16. Okay. And then we just want to combine like terms. We get x cubed. We got, I wrote it in a way so that my like terms are adjacent. That ends up being negative 8x squared plus 20x minus 16. Okay. So, with these presentations, I acknowledge that, trying to follow someone else's arithmetic is mind-numbing. I had the same experience. So my recommendation is, with these presentations, just try to get the gist of what's going on. Like, especially if we introduce a new symbol or concept, just try to get a sense for what that concept is or what the symbol means. And then it doesn't really sink in until you go to attempt it yourself. But trying to mimic what I'm doing will really feel like you're drilling a hole into your head, right? It's not a fun experience. it doesn't really sink in until you go to attempt to do it yourself. This is similar to the quote, the truth cannot be told, only realized. Right? You can tell somebody the truth, but if they're not ready to register, if they're not ready to hear it, like a lot of the deplorables and the Trump people, the MAGA campaign, I don't know how they identify themselves, but you know, with that whole crowd, a lot of the stuff is they don't care about the truth. They're just trying to promote somebody that they feel like stands for their ideals, right? They don't care about the truth, right? And so, but that led to like all this experience that we had, right? When you deal in egocentric ideals and you're only about the self, people suffer. I mean, it's already hard. You know what I mean? So anyway, what was it? Dang on it. I lost my train of thought. Oh, the true suffer. What was it about the true? Man, I was trying to get back to my original point and I lost it. But telling the truth, being honest. What was that point? Okay, I'm gonna have to let it go. Oh, the truth cannot be told, but it can only be realized. That's it. All right. You know, what I've found the challenge I give myself, I say it once and then I let it go. Like I give them, but you got to give people the space and time to realize this is the same thing. Trying to follow my work, it's going to be a challenge. I even still have that same experience when I try to follow other people's work. The only way I'm able to keep up is I've done it myself, and then I kind of go line by line, you know. And when they're seeing something new, I just try to get the gist of the presentation, and then I go back and try it myself. I never see it until I do it myself. You know, that's how the stuff goes from A B C D E F, A B C D E F. Okay. So the last part. So again, you know, you can't really see this stuff until you do it yourself. Was F divided by G? And what this means F of X divided by G of X. So F of X, it's right there. So this means we got our X squared minus 6X plus 8 divided by, man, the colors really help with this. Like it makes it pop. It's clear when I'm talking about something that's F related, it's fuchsia. When I'm talking something that's G related, it's green. It makes it, as opposed to if it were all black, like it would be, it makes it worse. It's so much harder to follow. But this makes different concepts pop off the screen. It's really interesting. I'm just talking about some of the psychology. Okay. Now, one thing that we need to note off the rip, notice that if X were 2, it makes a 0 on the denominator. So it's a good idea to go ahead and to notify or identify X cannot be equal to 2 because 2 makes a 0 in the denominator. Okay. Now, it looks like we can factor that numerator. So it looks like we can break it apart into some form like this, where we have X and X. Two numbers that multiply to give me 8 and add to give me -6, I think are what, -4 and -2? And then this X minus 2 just continues. We can cancel the like binomial terms or factors. And then we're left with X minus 4. And we still have to say that X cannot be equal to 2. Because even though that denominator is gone now, but because the 2 made the original expression undefined, we have to scrap it. We have to scrap it. Okay. Let's go to view. Single page. All right. All right, I think that's all of it. So A, we got -2, -1, -5 plus 6, -7 plus 10, all of that. Okay. And here's a type version of what we just experienced. You see the -2, you see the -1. I think these are good. X -820, yeah. Okay, so I think all of this is good. And it looks like they did the same thing that we did. Ooh, yeah, I feel like I got a second win now. Yeah, like, I don't know. I'm getting younger. I be needing naps. Like, I gotta take a nap. But it's all good. I need some agua. Give me just a moment. I'll be right back. So that's another thing that I like about being able to like do this from home. You know, if I need a nap, I got my hammock right next to me. I can take a nap. I got if I need water or whatever, a snack or something, I got everything right there. The bathroom's right there. I'm not like, I'm not being uncomfortable, you know? Okay, so let's keep going. So now, we looked at combinations of functions, and combinations is all it is: adding, subtracting, multiplying, and dividing functions. So then we have this concept for composition of functions. Okay, let's see what's going on here. So if f and g are two functions, the composition of function f with function g is written as f composed g, and is defined by the equation f composed g of x equals f of g of x, all right? Where the domain of f composed g consists of those values of x in the domain of g, where g is in the domain of f, right? So this symbol, oftentimes students confuse this symbol for multiplication, right? They try to multiply, and that's the wrong move. This open circle here, this is called composition of functions. This is read f composed g of x, and all it means is the second function inside the first function, right? And then so when we go to do domain of composite functions, there's a 3-step process that I typically do to find the domain of a composite function. Okay, let's just keep going. And this is just like a display of like where the domain for composite functions come from. But I feel like it's easier when we work a few examples on how to do it. Let me see my time. I'll give myself like 10 minutes. Okay, I think we got time to do this one. It's probably going to crash on me again. Okay. Give me a moment, I'll be right back. Let me check Zoom while this is rebooting. Okay, the chat looks clear. All right. Let's get back to where we left off. Right here. Add a page. I think we only need one page. And seamless. Okay. So given that f of x is x cubed and g of x is x plus 1, we're asked to find each of the following. Okay. So we have f of x equals x cubed, g of x equals x plus 1. Okay. So then part A, we're asked to find f composed g of 1. Part B, we're asked to find g composed f of 1. And part C, we're asked to find f composed f negative 1. Okay. So like this. So then for part A, f composed g. Again, what does this mean? This means the second function inside the first function. So this means f of g of 1. Okay. So let's go ahead and do g of 1 off to the side. That's going to be x plus 1, which is a 1 in this case. So that's going to be 2. So then what we're going to do is we're going to say f of 2. Okay. So then if we go ahead and do f of 2 over here, so there's going to be x cubed, but again, our x is 2. 2 cubed is what? 8. So then this final result here ends up being 8. Okay. So then for part B, we're asked to find g of f of 1. G compose f of 1. Again, this means the second function inside the first function. So this is going to be g of f of 1. Okay. So let's do f of 1 off to the side. So that's going to be what? 1 cubed. So then we're going to find g of 1. So let's do that here. G of 1, I think we did that one already, so it's 2. This ends up being 2. Okay. Then C, C asks us to do f of negative 1. F compose f of negative 1. This means f of negative 1. So if we do f of negative 1 first, it's going to be negative 1 cubed. That final result is going to be negative 1. So then if we pass negative 1 through f again, the same argument is just going to be negative 1. Okay. All right. Eight, 2, and negative 1. Okay. Let's go view. Let me see the time. Okay. You see the 8 there, the 2, and the negative 1. Let's see. Let's see something. Okay, they didn't talk about it. I want to say I went through this one in my pre-recorded lecture. So I'm gonna just leave a note to say see the pre-recorded lecture because we're just out of time. There's there's something else that I want to get to. I'm gonna say see pre-recorded lecture. Okay. Okay. And I think it's gonna crash on me again because I need to add another page. Okay, it didn't crash that time. Okay, so given this F and G, we only have time enough to do part A. It's asking us to find F compose G of X and find the domain. Okay, so then for part A, we have that f of x equals x plus 1, g of x equals 1 divided by x, okay? And part A asks us to find f compose g of x and its domain. So I want to do this one just to showcase how to find a domain of a composite function. Okay? So first, let's find the simplified function. So if we're going to find f compose g, and this will be it for the day. F compose g of x. This means the second function inside the first function. So this means f of g of x. This is going to be f of, now our g of x is 1 by x. Okay. So all we're going to do is write f like normal, but replace each x with the green thing. So we got x plus 1, but the x gets replaced with 1 by x. Okay. So the simplified function is going to be this 1 over x plus 1. So then to find the domain of the composite, let me kind of highlight the 3-step process that I recommend. So let me see. To find, let me see, the domain of a composite. I'm gonna just kind of shorthand it like this. So first we want to find the domain of the inside function. Then we want to find the domain of the simplified function. And then lastly, we want to take their intersection. Okay. So then for the domain of f compose g, when we do the inside function, our inside function in this case is going to be g. So then the domain of g, okay. So g is a rational function. With rational functions, the domain is all reals except any x that makes the denominator 0. So the domain of g is going to be everything except 0. Okay, I'm going to shorthand it by writing x is not equal to 0. That's the inside function. And then the simplified function, simplified, is this guy here. This 1 over x plus 1, right? The only restriction there, again, we don't want to divide by 0. So the domain, the only restriction there is that, let me see, domain of the simplified, we say x is, it can't be 0 again, right? It just happens to be the same. So then the third thing is we want to take the intersection of these sets, right? So a set intersects itself, right? The first result we got was x is not 0. We want to intersect that with the same thing. So what do these two sets have in common? They end up being a set itself. A set intersect itself is itself, right? So then to write this in interval notation, let's start by looking at the graph. Here's x equals 0. We want to capture everything except 0. So that means we want all the numbers to the left of 0. We want all the numbers to the right of 0. But because we don't want to include the 0, right? We don't want to include 0. So the 0, we put a parentheses like this. This basically means you can consider any number is going to work except 0. Any real number is going to work except 0. So then now we're ready to capture this in interval notation. The far left is going to be what? Negative infinity up to 0. And then we're going to go from 0 to infinity. Infinity always gets a parentheses because we never reach it. 0, I guess, unless what? This is the MCU universe. You have the center of the universe and eternity. I don't know. That was in Multiverse of Madness. Anyway, and the 0 in this case gets a parentheses. And we want to combine these two sets by using union. Union means a solution will work if you choose something from the first set or the second set. Okay. And that's our solution there. Okay. There should be questions, but because of these kind of topics, this is why I encourage you all to work together. I can understand, coming from me, it's one thing because I went through the same thing, right? So hopefully at least some of your classmates are getting it, and then they're willing to help, help you all, help each other, right? And if none of your classmates are getting it, then the tutor should be able to help you with this. So between me, certain classmates, and the tutors, and Pearson, because Pearson explains each example as well. You have a wealth of support and resources, right? You just got to use these things. Okay. All right. So if you have any questions, now's the time to ask. Let me go ahead and make a copy of this available. So what I'm doing is loading a PDF version of all the stuff that you saw me writing, making it available. So you can access it and call it later if you need to. If there aren't any burning questions here, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. Peace.